All right, this part I'm really excited about. We're going to use some design patterns, specifically dependency injection and error propagation. Both of these sound fancy, but they're actually super simple and super helpful. Let's start with dependency injection. And I think the best way to explain dependency injection is to first show you one of the problems that it solves. So again, let's imagine that we come back to this 6 months later, we don't remember anything, and we're trying to understand. So we start with main.rs, and we follow this reference, and we end up here in lib.rs in this run method. And we can see that we're doing some tauri setup stuff. We can see we create a shortcut. And then we can see that when the shortcut is pressed, we call this handle hotkey flow function. That returns some filters, and we emit those filters to the front end. And we just skipped over a bunch of the building blocks of our app. And if we want to learn more, we have to follow this reference, dig into this function a little bit, and we can see, oh, handle hotkey flow depends on this item text to trait site filters function, and that depends on a stat mapping. And where does the stat mapping come from? If we follow that reference, we can see, oh, fetch stat mappings depends on an HTTP client. And at this point, we have a more complete picture of our app, but we kind of had to dig for it. And dependency injection says, hey, instead of burying our dependencies in the guts of our app, what if we created them up front and passed them down? So let's see what that would look like. For fetch stat mappings, we'll pass in a client instead of creating it. And we'll see that broke this function here. It's now expecting a client. And a client is a really common dependency, but a dependency can also be data like it is here with our stat mappings. And a dependency can also be a function, which is what I think makes the most sense here. So we'll get rid of these two lines and we'll come up with a new function name, item text to trait site filters. And we'll pass that in as a dependency to this handle hotkey flow function. And now that nothing in this function is async, we don't need the function to be async anymore either. And finally, back down in our run method, we can start to stitch this together. But first, let's create a little helper function to create an HTTP client. Then we'll create our client and we'll fetch our stat mappings. You can see we got some red squiggles here. If we hover over that, it says await is used inside non-async closure. So all we need to do to fix that is use a blocking async runtime. And next up, let's make a new function right here that takes item text and returns either trait site filters or an error. And we'll use our existing item text to trait site filters function and pass in that stat mappings that we got. So now when our app starts up, we'll get this stat mapping once, we create this function, and no matter how many times we call this function, we won't have to fetch that stat mappings over and over again. Next up, we want to pass that function into our handle hotkey flow function as a dependency. And now that this function isn't async anymore, we don't need this async runtime. And since we don't care about this released shortcut state, I'm also going to simplify this a little bit. And this is already looking much better. Let's also give the same treatment to the search trait site function. And we'll also give this hotkey stuff a home. So we'll make a new file. We'll call it hotkey.rs. We'll move it to the right. And then we'll copy over our handle hotkey flow function. We'll make it public. We'll copy over this control C stuff. And we'll fix our imports. We'll import it in lib.rs. And we'll reference that here. Easy. Okay, let's take a breath and see what all that got us. So now in our tauri run method, we can see we do some tauri setup stuff. We create an HTTP client. We use that to get some stat mappings. We use those combined with item text to get some trait site filters. We create a shortcut, and then we trigger handle hotkey flow, which uses that item text to trait site filters function. We return some filters, emit them to the front end. And then we can see we also register the search trait site function, which uses those filters and an HTTP client to get back some trait items. And that's all spelled out up front in our lib.rs file. I remember I first learned about dependency injection as a tool to get more control over my tests, and it is great for that. For example, you could pass in an HTTP client that always times out, and you could test how your app reacts to that. Super useful, super important. But as I used it more, the thing that really made me fall in love with this pattern is that it encourages you to show these building blocks up front, and in my opinion, really improves the composition and readability of an app. Okay, now let's talk about error propagation. In a way, dependency injection and error propagation are two sides of the same coin. Dependency injection says, let's pass our dependencies down, and error propagation says, let's pass our errors up. So the idea is that anything that can error should pass that error all the way up the chain as far as it can. And thankfully, we're already using that pattern all over our app, and that's partially thanks to Rust. Rust has this built-in result type meant for returning errors, and Rust also has this question mark operator, which will immediately return an error. It's even described in the Rust docs as literally error propagation. Love that. But there is a problem here. If this setup function returns an error, the error message will show up in the terminal if we run our app from the terminal, but our users aren't going to run this from the terminal. They're going to run it as a regular Windows app, and by default, tauri won't show them the error message. The app will just close. So imagine you download this trade tool, you launch it, and it immediately closes without any indication of what happened. That's not an acceptable user experience. So we're going to install the tauri dialog plugin, and we'll add that to our tauri build step. And we'll make a little function that'll pop up our error message. And then instead of this question mark operator, we'll use unwrap or else. And what this does for us is we either get the client back, or if there's an error, we'll show the error to the user and then shut down the app. And we'll do the same thing when we fetch our stat mappings. And the reason that we shut down here is because these are what you call fatal errors, meaning that if our app can't get a client or these stat mappings, nothing else after that's going to work. So the best we can do is tell the user what happened and shut her down. Okay, much better. So with these two patterns, we get to see our dependencies up front and our errors up front. Very cool. Couple more cool things about these patterns. These are some of the most commonly used patterns. So that means if you're reading somebody else's code or they're reading your code and it's using these patterns, immediately you're closer to understanding each other. And these patterns apply to pretty much every programming language. And in my opinion, that makes them even more worth learning and using. So with all that said, let's make a new checkpoint and we'll call it dependency injection and error propagation done. Nice. Okay, so next up, we're going to release our app and set up auto updates. And we will go into each part of this in detail, but before we do that, there's kind of a lot of moving parts here. So first, I want to just quickly go over how all this is glued up at a high level. So here we've got our computer, github.com, and our app. Our computer has our Git repo on it with our source code. And from a terminal, if we run git push tag, that triggers a workflow on GitHub. And that workflow creates our installer, signs it with a private key that we'll configure as a GitHub secret, and then publishes that as a new release. And for our app, we're going to be using the tauri updater plugin. And the way that works under the hood is at first it asks, where do I even look for an update? And for that, it looks in our tauri configuration file for an endpoint. We're going to configure that endpoint to be the URL for our latest GitHub release. If it finds a newer version there, it downloads that version, validates it with a public key also in our tauri configuration file, and then installs that version. So there is a fair amount of plumbing here, but the nice thing is that once it's all set up, all we have to do is push a tag and the rest of this process happens automatically. Pretty cool. All right, let's set it all up. Okay, let's deploy our app. I'm here on the tauri GitHub docs, and if I scroll down a bit, there's this example workflow that will build a Windows installer and publish it to GitHub so that people can download and install our app. So we'll get into this line by line in a second, but for now I'm just going to copy it. And then in our app, we'll make a new folder. It'll be .github. Inside of there, we'll make another new folder called workflows. And inside of that, we'll make a new file called release.yaml. And we'll paste that workflow. And we're going to simplify this quite a bit. Instead of triggering this when we push to the release branch, we're going to trigger this when we have a tag that starts with V for version. And we only care about the Windows platform, so we're going to delete these other ones. This line here checks out our source code, and we don't care about this Ubuntu specific step. We're going to get rid of this caching line when we set up Node, just to keep things simple. And this section here will install Rust, and we can delete this bottom part because it's specific to Mac. And we'll delete this Rust cache step, again, just to keep things simple. And here we're using npm. So instead of doing yarn install, we'll cd into our app folder and do an npm install. And here's the step that actually creates our Windows installer. So we're going to add a project path, app. And for a tag name and release name, we're going to change this to github.refname, which will be the name of our tag. And finally, we'll change release draft to false so that we don't have to mess with drafts. And now just to summarize, this workflow will trigger when we push a tag starting with V for version. We'll check out our source code. We'll set up Node. We'll set up Rust. We'll do an npm install. And then we'll create and publish a Windows installer. So now we'll make a new checkpoint. We'll call this release workflow done. And now we need to set up a repo on GitHub. So here I'm logged into GitHub. I'm going to come up to the right here and click this plus sign and click new repository. We'll call this the chiseled course. It'll be public. We'll click create repository. And down here it says push an existing repository from the command line. That's what we want to do. So we'll copy this first line. And then we'll do git push origin main. And now if we refresh, we'll see our source code up on GitHub. Nice. So now we want to trigger this workflow. So we're going to come over to our cargo file. We'll change this version to be 1.0. We'll make a new checkpoint called v1.0.0. We'll push that. And then we'll create a tag, v1.0.0. And then we'll push that tag. And now if we refresh, we'll see this orange dot here. If I click that and then click details, we get to see our running workflow. Cool. And our job completed in a little under 8 minutes. And if we come back to the repo homepage and click releases, that workflow created this release and published these installers. So now anybody can download and install our app using either one of these installation files. Pretty cool. And we can release a new version anytime we want, just by updating the version, creating a tag, and pushing it. Awesome. There is a slight problem though. In order to get an update, our users would have to come back to our GitHub repo and download it manually. It'd be way better if our users could get the latest version automatically through our app. And the good news is, it's pretty easy to set that up too. I'm on the tauri docs for the updater plugin, and there's a lot in here, but I'm basically going to break it down into 5 small steps. Step 1, in our terminal, we're going to run the npm run tauri signer generate command. And we won't enter a password. And what that did is generate a private key and a public key. We're going to save both of these for later. And these are basically used together to authenticate our updates. The details of how this works is some brain-melting cryptography stuff. We're just going to cover how it's used in practice. So step 2, we'll add the private key as a secret to our repo. So here's our repo. We'll go to Settings, Secrets and Variables, Actions, New Repository Secret. The secret name will be tauri signing private key. We'll stick our private key in here. And now we'll come over to our release.yaml, and we're going to add 2 things. We'll add the new secret under env, and at the bottom here, we're going to add include updater JSON true. We're going to come over to our tauri configuration file, tauri.conf.json, and I'm going to copy this in from the docs, and we'll clean this up a little bit. This will be make stuff with me, chiseled course. And this will be our public key. And while we're in here, we're also going to snip this version so that it uses our cargo files version instead. That way we just have one less file to update. And finally, step 5, we'll update lib.rs to check for a new version. So first off there, we'll add the plugin to our cargo file. We'll add it as a build step. And we're going to add a new function straight from the docs. And we're going to clean this up a lot. We don't care about things like chunk length or how many bytes we've downloaded. And if we do find an update, we'll pop up a little message. And let's also rename this to just show dialog, since it doesn't have to be an error. I'll use the blocking runtime again here. We could run it in the background, but if we get an update, I don't want our app to pop up later in the background. And let's make a new checkpoint. We'll call it auto update done. And we'll also make a new version. So we'll call this 1.1.0. And while we're in here, we'll also change our app name, the description, the author. And now we'll bump the version. We'll push that. We'll create a new tag. And we'll push that too. And now back in our repo, we can see that new version's cooking. Nice. So now we're going to make sure that all of that is working. Let's make another version with a few minor changes, and we'll see if we can auto update to that version. For a change, in the front end, there's a few headings that are kind of taking up a lot of space, and I don't think that they're necessary. Like this one here, Path of Exile 2 Trade Tool. We can get rid of that. And this one here, Select Trade Filters. And this one here, Search Results. We can get rid of these, and I think that people will still know what to do. And let's also make the window size something more reasonable. And now let's make another checkpoint. We'll call it snip front end headings. And we'll also bump the version. We'll do 1.2.0. We'll push those up. And we'll also make our tag. And we'll push that up as well. And now we wait for this workflow to finish. And now we're ready to try this out. So v1.1.0 supports automatic updates, and version 1.2.0 got rid of those headers and changed the window size. So we'll download and install the older version. We'll run that. The huge window opens, and here we go. It says update found installing. Ooh, and here we can see the correct window size. And here we've got our trusty boots. Let's press the hotkey. Nice, no headers. That tells us that we successfully automatically updated to the most recent version. Awesome. And that concludes this course. We did it. We built the Path of Exile 2 trade tool from scratch. We covered a ton of ground. We came up with a design. We built a prototype. We got a ton out of our AI assistant. We used the heck out of the tauri framework. We figured out the trade site API. We did some debugging. We made a test. We used some design patterns. We deployed it. Awesome. Thank you so much for watching. I'm happiest when I'm building stuff and sharing that with people, and your support means that I get to do that. So again, thank you so much. Subscribe for more, and hopefully I'll see you in the next one. Bye!